Welcome back. This is a supplemental video to show the solution to the problem that is raised in the kinematics review. If you'd like to view that video lesson, the link is down there in the description. This turned out longer than it should be because I will present the solution in three ways. The first one is just using the basic concepts. This is the longest solution usually. The second is the shortest using the formula. And lastly, graphs for those who like the challenge. So let's get to it. Let's recall the problem. Which of these two objects will be able to cover more distance in 60 seconds? To solve this, we need to identify the things we know about each case and line them up against the kinematics formula that we know. By now, these equations should come to you as concepts, not just math. Let's put those equations here for a quick reference. For case 1, the time total is 60 seconds. It says it starts from 1 meter per second, so b sub I is 1 meter per second. Then it says it speeds up at a rate of 0.2 meter per second. That is acceleration. So acceleration here is 0.2 meter per second squared. What does it need? It requires you to find total distance. Let us derive an equation for that from these kinematics equations. That is this one, because you can see there distance total. We transform that to this equation. If you still struggle how to derive equations like that, I suggest you review your algebra, really. If you dive head on to kinematics without a good math, you will be disappointed of how difficult this kind of physics is. When the reality is, you aren't really prepared yet with the right tools and skills for these problems. Okay, moving on. This equation demands two variables. Average speed, we don't have this. What we have is instantaneous, and then time total, we have that. Now, our main problem is finding the average speed. We can see one concept there in our kinematics equations. If only we have another instantaneous speed, we can get an average. Which brings us to this realization. Isn't that it says the speed is changing by 0.2 meter per second for 60 seconds? That leads us to this final speed in your acceleration. Let's do that. Let's derive first an equation for that final velocity. Okay, there. You may pause this if you want to try that derivation on your own. Plug in there the variables that we know, keeping in mind to put the units just to see if they are in the proper dimensions. Okay, that's the final speed. Let's go get the average speed. Let's just do this in our head. To get the average of the initial and final, combine them and divide by 2 because that is how you compute for average. Try that kind of solution from time to time. Sometimes students use the equations blindly without really thinking what's in there. The main reason that most of the time they cannot see the solution when it is right there because they don't see this formula as concepts, but just that, large chunks of math that are difficult to chew. So if the initial is 1, the final is 13, the total is 14, divided by 2, that's 7. So the average speed is 7 meters per second. And oh, look at that, the end of the tunnel. Let's plug in the variables with their values. That gives us 420 meters. Let's conclude the solution. This car covers 420 meters in 60 seconds. Okay, let's compare this to the second one. Let's line up the kinematics equations here. Then list down the givens. Total time is still 60 seconds. It says speed is 10 meters per second constant. So that is also the average, right? We are required to find the total distance. We have derived this already in our solution a while ago. Let's get the solution fast and put the variables there. Okay, that is really quick, 600 meters. Let's conclude this. This car travels 600 meters in 60 seconds. So it is the second car that will cover more distance in 60 seconds. If it is a race between these two, the gap is 180 meters on the first 60 seconds. This part onwards now is actually the default mode in doing problem solving. A quick work using a set of formulas. In kinematics, usually you just need this 5. For the expert ones, for this level of kinematics, just these 2 probably, but who is an expert anyway? So let's get to it. List down the givens for the first case. Time total is still 60 seconds. Initial speed is 1 meter per second. Acceleration is 0.2 meter per second squared, and we are required to find the distance total. When you are doing this style, I suggest you line them up that way, because the next part is you inspect your formula and find that one that has these variables. Start with the one that you need, distance total. Okay, you have three choices. Next, which one there has everything you have? Not this one, it needs the average speed. Not this one either, it needs the final speed. If we are lucky, it must be this one. It needs initial speed, we have that. We have the time as well, and we have the acceleration. That's it. Let's fire it up. Okay, that's really fast. We get 420 meters. Did you see that this will only work if you listed down the given and the proper symbols, right? So don't write there in the given SPEED is equal to 1 meter per second. You write V sub I equals 1 meter per second because you see in your formula a V sub I, not SPEED. The second case is already solved. It won't get any simpler than that you've seen in the first set of solution. Let's begin now using graph to solve this problem. Projectile motion is grade 9 science. You should have studied graphs of motion in your grade 7. Forgive me for not focusing on elaborating how it is done while we use this solution. Okay, let's set up a graph for this problem. A speed time graph gives us the distance as the area below the graph. So let's do that. Speed here and then time in the y. Now we put in the graph the details that we know. The initial speed is 1 meter per second. That goes here and trace that point with a dotted line. Next, our context is 60 seconds. So let's put that on the t-axis as well, close to the end. Then trace that point with a dotted line as well. Then how do we put the acceleration there? Let's begin with this idea that the speed is increasing. So we will put a line with a positive slope, meaning we are looking at v-axis to keep going up while time progresses. So it looks like this. Notice that it crosses the dotted line coming from the t-axis. If we cross it too with a horizontal line from the v-axis, it gives us an insight that at 60 seconds time, a speed that we don't know is somewhere here in the v-axis. Okay, let's get that unknown. The slope of this line is 0.2. Slope is rise over run, so that gives us this relationship. Here is the rise, and there is the run. We know by inspection that that one is 60 seconds. This gives us this rise is 12, meaning the gap here is 12 and that one is 60. Therefore, this one is 13 meters per second. You don't need this, but let's put it there in case the problem has several questions. To find the distance, we need the area under the graph. This rectangle here and the triangle there, and indicate that as the distance. The rectangle is base times height. This gives us 60 meters. While the triangle is 1/2 base times height. Let's show that height, this one. That's 1/2 times 60 seconds times 12 meters per second. Careful here, 12, not 13. This gives us 360 meters. That's it, like magic. 420 meters. Now let's solve the second case using a graph as well. Let us recall the problem. Distance covered in 60 seconds by an object that moves at a constant speed of 10 meters per second. Okay, now put up the v and t axis and indicate the known variables. The speed is 10 meters per second and trace that point in the graph, while the time is 60 seconds. And do the same, trace it with a dotted line. The object is not changing its speed, so from 0 to 60 seconds, it is still 10 meters per second. That line is this. To find the distance, we get the area under that graph. It is a rectangle, so that is base times height, giving us 10 meters per second multiplied by 60 seconds. This area is 600 meters. The total distance is 600 meters. There. This is what is amazing with kinematics. You get problems, but you get to choose how you will solve them. But just with real life, the choice becomes limited when resources are limited. The only difference is that resource of skill and knowledge is just waiting for you to give it more time and practice. This concludes the supplemental video. Now it is your turn to show your solution.